Okay, probability or discrete probability distributions. Here what we have is the rolling of a die. So you have a die and it's got different numbers on it. I mean, we're all very traditional die. It's got the 1 or the 2 or the 1, 2, 3 or whatever else. And if I roll the die, I have the equal probability of running any one of the 6 numbers. 1, 2, 3, 4, 5, 6, they all are the same. And the probability of running those is 1 over 6. And we've already talked about that. And so now what I'm trying to figure out is what does the overall big picture look like? And if I were to graph these and say 1, 2, 3, 4, 5, 6 on a rate of, say, 100%, or in this case, 1/6, 2/6, and so on, each one of these would have the exact same distribution or the exact same probability. They'll have a probability of 1/6. Discrete means that these are independent, right? You can't be anywhere between the 5 and the 6. So you're either on the 5 or you're on, let me erase that, or you're on the 6. You can't be in the middle. There's no 5.5 here. And that's what we mean when we say discrete. Discrete to us means one or the other. There is an island. And so that is all that discrete probability distributions really mean, is that they give us this overall picture of what the entire thing looks like. And that's pretty important, or it will be in a second. The properties of discrete distributions are pretty simple. Let's go over those real quick. The probability that x will be equal to any x is equal to, yes, all the x's. So I can actually reduce. The probability that x will be rolled is the probability that x is equal to 1 plus the probability that x is equal to 2 plus the probability that, and you get the picture, all the way till the probability of x is equal to whatever the largest n is. In this case, that would be a 6. All right, if I add all of those together, they're going to add up to 1.0 or 100%. What does that mean? It means that if I pull what is the probability, if I roll a die, what is the probability that I'll get a number? If I roll a die, it'll be 100%. Okay. Probabilities must be between 0 and 1, or they will not happen, and 1, they must happen. All right. And finally, the probabilities are additive. So, what is the probability, for example, of rolling a number that is greater than 3? Well, what are all the numbers greater than 3? Well, this is the probability that x will be equal to 4, plus the probability that x will be equal to 5, plus the probability that x will be equal to 6. And since these are all 1/6, 1/6, and 1/6, I can add all of those together to get 3/6. This is plus and plus, which obviously equals 1/2. So what is the probability of rolling a number greater than 3? It is 1/2, or 50%.